what you wanna see is what do you have left when they disappear? And is two less than, this two is less than the 10? True. It means I don't care what you put in for x, when I multiply it by 3, I'm going to multiply it by 3 on both sides. So this statement will always be true. So in other words, you can put in any number for x. We're going to multiply it by 3 on this side, multiply it by 3 on this side. It's still going to have less numbers on this side than here. So that's why it's always a true statement. When this scenario happens, these guys cancel out. Now, if they didn't cancel out, if you had a 3x here and a 2x here, then you're gonna have your inequality statement where x is less than 10 or whatever.
Okay. Okay. So just any true statement is anytime.
If it's true, right. If this was like this and it says is -2 greater than 10, let's say we ended up with that. You know, this could have been a -2 here, right? Now I have is negative, oh, that's still true. But let's say it ended up this way.
Okay.
Is -2 greater than 10? No, -2 is a smaller number. So then your solution would be empty set.
Oh, see, I didn't understand why it wasn't an empty set.
Okay,
Because it
because
is
this
true.
is
Instead
true.
of dividing by 36, we'll need to take away 36D from either of those, and that eliminates those, I think. So that we just have
You end up with the true
anything
statement,
is
where you at?
less than D, and so this one right here, I divided by 36 in the end.
You don't have to,
I
see,
can
you
just
don't
take
end
away
up,
36D.
you don't have a D, you're gonna take away 36D.
You want me to get rid of the variable entirely and it'll still make sense, I understand now.
Okay. Okay. But see, you started it, and I think everybody in the room has the same question, so don't be afraid to email me, cause that helps me when you come in the next day, you're not sitting there, I still didn't get that.
I thought it still made sense with one of the variable left.
You don't have a variable left, cause you're subtracting 36D to get them all into one room. So your D's went bye-bye.
I will, that needs to be turned in by the end of class, right?
With your quiz, yes.
Okay.
Nicholas, are you Nick or Nicholas?
For Nicholas. Yeah, thanks again for the notes.
Are you I?
Okay.
Okay, okay. I mean, I don't say okay, it's okay.
Oh, I know.
When did you get my email today? Check your email. Can you pronounce your name, Adrian? I'm horrible with names, so I have to do that. You're Cordero, right?
Correct.
No short, no anything, that's it? Got it. Is it Darrow or
Yeah, Darrow.
Darrow?
Yeah, so it's Cordero. It's
Got it.
actually Spanish like Cordero.
Oh. I took Spanish for 5 years, and at the end, all I know is La Biblioteca, and I'm horrible at it. And it all started when they said, what's your name? And my first name is Deborah. Well, how would you pronounce that in Spanish?
don't speak
Sorry about that.
Oh,
I'm
okay,
just Cuban and Jamaican descent,
Okay.
so
all right.
my family.
How would you pronounce Deborah? See, there isn't
That's what
any.
I mean.
So if I was a Juan or if I was a whatever, they all had nice Spanish names and my
She's
name
taking-
was never
she's
Spanish.
taking
So I
away
was at a
from both sides.
default from day one.
Oh, you were telling me that?
Yeah.
Okay,
You take away the 36D from both sides,
okay.
and then you divide by 0.
Can't divide by 0.
Can't divide by 0.
But we established yesterday in the study group that you can divide into 0.
You can
What was
divide
that
into
here?
0, yes. Can't put the 0 on the bottom.
So should I have also not added the 28 earlier so that I'm left with something on that side?
No, you could have 0.
I can have 0 on that side.
Less than 34, is that a true statement?
Yes, it is.
Yeah, so that's what your work would be, you'd look at it and say, well, that's a true statement, but I lost the variable, therefore this is your solution again.
I overthought it so much I forgot what a 0 was.
No problem. Okay, we're gonna get started. How many of you didn't like problem number 5 on your homework? Did everybody else get it? Now, I'm gonna give you a little heads up. I give you the answers to the homework, right, at the end? So, some of you are just writing in the answer and not showing me the work on the problem, and you think that's done. But if I pick that problem on a quiz or a test, you're gonna get yourself into trouble. So again, I'm gonna stress again, email me when you get stuck, take a picture of what you've done, and just say, you know, I don't get why the answer is this or whatever. But problem number 5 was a hard problem. And if you don't understand why the answer was all real numbers, you needed to email me, or you ask somebody that you're sitting next to, or you come a little early, you stay a little bit after to figure out how to do every one of the 15 problems that I give you for homework. Because any one of those could be the ones that are on the quiz, or the ones that are on your exam worth 100 points. You wanna make sure you can do all 15 problems, okay? So this problem number 5, if you look at your problem number 5, this one's different, but I wanna show you a different one so you can go back and look at yours and figure out what you did wrong. Problem number 5 sorta looks like this in the fact that the left side and the right side of the inequality have the same number of x's on both sides. That means they're going to disappear at some point, where you're taking minus 3x from both sides, and this goes away and this goes away. You don't have any x's anymore. And when you don't have any x's anymore, you got 2 scenarios. Either it's empty set or it's all real numbers. When it's an inequality, you bring down your numbers here, and we say, is 2 less than 10? Yeah, that's a true statement. So now your solution, because we lost the variables, is all real numbers. Why is it all real numbers? Because I'm gonna multiply whatever number you pick, a million, a jillion, whatever number you pick, I'm gonna multiply it by 3 on this side and multiply it by 3 on that side. It's gonna be the same number. That's why when we subtracted these, it went away, because you're doing the same thing to both sides. But what you have left, you gotta see, with that inequality sign, is it a true statement or a false statement? If it's true, it's all real numbers. If it's a false statement, if it turned out to be 2 is greater than 10, you go, 2 isn't greater than 10, then your solution would be empty set. Now, what brought this on is an email from somebody in the room, and somebody else coming in early to get that question taken care of. If you don't talk to me and tell me where you're stuck, I'm assuming you're all A+ students and you got them all. So don't feel bad emailing me. Don't feel bad, talking to somebody in your class. If you're stuck, probably 99% of the students in the class are stuck also. Okay? You gotta become friends with everybody in the room, including me. All right, put your quizzes away for right now. You don't wanna do the quizzes during the lecture, because the lecture is what's gonna be on the next quiz, and also it is a review for the quiz that's on your desk right now. Today we're doing absolute value. Raise your hand if you know what the heck an absolute value is. Okay, I got 3 out of 24, that's 1/8, that's about 12% of the class. I got 90% of you almost that have no clue what I'm gonna talk about today. So you need to take out your white packet, turn to day 4, and this is new material. It's not taught in the 92 class. It's probably something you haven't had maybe since high school took phones away. Just watch. If I told you guys that you all used absolute value today, if you drove a car, or you were in some vehicle that was on a road, would you believe me? You should, because I don't lie to you guys, right? So you guys used always absolute values every time you drive on a road. Why? Because the person that built that road used absolute values. Do you know how wide a road has to be?
Not technically.
Huh?
Not technically.
Any engineers in the room? There's an engineer. Have you ever seen those guys sitting on the road that looks like they have a camera and they're going down a road, trying to build a road or fix a road or something? And they have those cameras. Well, what they're doing is they're measuring that road. And a 2-lane road inside town, in town of Tucson, has to be 25 feet across. Did you know that? What happens if it's not 25 feet across? What if it's only 10 feet across? Everybody's gonna hit everybody, isn't that sort of important?
Mm-hmm.
So what I'm teaching you today keeps you from not getting into an accident. Really? Yeah. You see, when they build any road inside Tucson, it has to be 25 feet. But they have what they call a little variance. It can be a half a foot greater than 25 foot, or it could be a half a foot less than 25 foot, and you can still drive on that road and not hit the other guy coming the other way.
Mm.
Is that sort of important?
Mm-hmm.
Yeah. All right, so I'm grabbing your attention because this is important. There's lots of ways you use absolute values, but they don't say it when you're using it, but you gotta learn how to do it, okay, today. All right, so up here I have my house. I live on this street right here that's got all those numbers on it. You see it? Here's my house. I have a little puppy, and the dang little puppy got loose. Really? The little snot ran away. I saw a neighbor and they said, "Oh, your dog's 5 blocks away." And I'm going, okay, here's my street. 5 blocks away could be over here, could be Fido. But good old Fido could be on the other side 5 blocks, correct? Now, how do I write that mathematically? Well, I could put x equals, x is Fido. X could be 5, or x could be at -5 house. Do you agree?
Mm-hmm.
Well, in math, we're lazy. We don't like to write 2 equations with the word or in between. Remember that word or from last Monday? My husband's tall or blonde, or tall and blonde. Well, with absolute values, I use the word or because Fido is either at 5 or Fido could be at -5. Do you agree?
Mm-hmm.
He's 5 blocks away. All right, in math, we don't like to write a lot because we can't spell. So this is how I write where Fido is. I put Fido's name inside what we call absolute value blocks. And that tells you, and then this number over here is always positive. And then what you need to know is that the solution could be positive or negative. It's a shortcut for writing a compound equation with the word or, where your answer is either the positive or the negative. Now you're going, oh boy, now she's going into a dark side. All right, so let's go and look at what a homework problem is going to look like starting tonight. It's going to look like this. Do you see the absolute value bars?
Mm-hmm.
The red ones? I call them goalposts. When you see the goalposts equal to a positive number, the work you have to show is this, and I want you to take your notes, and I want you to circle this or write it in if it's not written in. No absolute value bars in your work. If you show me on your homework when you're solving these problems, you're going to put in an absolute value bar, I'm going to mark it wrong. Because absolute value bars is used to show you a distance. This blob is going to be equal to 5. Now, I got to figure out what number do I add to 3 to get a 5, or what number do I add to 5 to get a what? Or add to 3 to get a -5. So look at the math problem you gotta do. You drop the absolute value bars and you put it equal to the 5. Then you have to supply the word or today. That's the hardest part of your homework. Last night, I gave you the word or, I gave you the word and. Today, you're gonna have to put the word or in. Give me what's inside the absolute value bars, but now you put it equal to what? -5 also. So what you're gonna have to do is you're gonna have to solve 2 math problems. Now, how do we solve this? We did it the first day of class. We're always going back to that first day of class. Subtract your 3, you get x equals 2, or subtract your 3 over here, you get x equals -8. You put your solution in those brackets, not in interval notation. Not interval notation. It's the funky brackets, cause it's 2 solutions. All right, now let's look at 4 scenarios. I'm done with 1/3 of today's lesson. If I give you an absolute value problem equal to a positive number, and there's nothing inside those football goalposts but the football, the S or the X or whatever letter it is, when you have a single variable inside equal a positive number, look what I'm telling you. No work, hee-haw. Am I gonna give you that problem? Probably not. Because there's no work. You just put on your paper S is 0.003 or S equals -0.003. You just put your funky brackets and you put what that number is and it's opposite. How easy is that? If I give you an algebra problem inside equal to a positive, notice I'm underlining this, you write it in or you underline it if it's on your paper. You have to give me the math problem with no absolute values equal 5, or the math problem equal to -5. Notice I'm supplying the word or, because it means Fido is over here, or Fido's on the other side. You gotta give me that word or. If you don't, I'm gonna assume it's an and, or it's just 2 math problems that doesn't have an absolute value. You gotta practice putting in the word or between your 2 math problems without the absolute values. Now you're gonna solve this exactly the same way. These little problems, aren't these easy? It's the first day of class. But you gotta do 2 of them for the price of 1. Oh, really? Yeah. So what do I have for a solution? 7/3 and -1. I put it in the funky brackets, not in interval notation. If you have an absolute value equal to a negative number, can my road be -25 feet across? A distance can't be negative. If it's negative, it doesn't exist. Do you agree? So if I give you, and I will be doing this to you, give you an absolute value equal to a negative number, there's no work. You just put in empty set. You go, hee-haw, good job. Because that's.
Nothing can be a negative amount away from 0.
Right. Good. It's not possible. It's sort of like this scenario. If you have an absolute value equal to a negative, you just say empty set. All right. Now, what kind of math problem am I gonna give you for your homework? I'm gonna give you a math problem that looks like this. It's got the absolute values in it, but it's not isolated. We always have to have the absolute value bars. The football goalposts have to be all by itself. Okay, so what's the first thing I have to do? I have to simplify this first and subtract 8 from both sides. And when I do that, now I have an absolute value by itself. Now I have to analyze. Do I have a positive number on the right side? No. So now, after I have this statement, I can say the solution is empty set. When it's this way, you haven't proved to me why it's empty set. To prove to me why it's empty set, anytime you had those football goalposts equal to a negative, you can say empty set. If it's equal to a positive, you gotta drop the goalposts, put your math problem equal to the positive and the negative and solve. You'll get 2 solutions. Easy peasy, right? Okay, I have 5 problems down here. Problem 1, problem 2, problem 3, problem 4, problem 5. Which 2 do you not have to show a stick of work?
2 and 5.
2 and 5. Why?
2 is just negative 2 and 2, and 5 is no solution.
These 2, so if I gave you these 5 problems for homework, these 2 you don't do a stick of work, because you always look at your problem first to see if there's nothing inside but the variable. I'm not gonna give you this one. But this one I would. And a lot of students are gonna sit there and put x plus 6 equals -2, x plus 6 equals +2. No. Absolute value is a distance, and you can't have a negative distance. All the rest of these, problem number 1, problem number 3, and problem number 4, you're gonna have to show some work. 3x equals 15, or 3x equals what? -15, because it could be on the left side, it could be on the right side of 15. Easy peasy? Okay. Let's go to the next one. The hardest problem in this section. What happens if I give you the 2 goalposts on any football field? On any football field, you have 2 goalposts, right? One on the left side, one on the right side, if you're sitting in the middle, right? So what happens if I give you a math problem with 2 goalposts? What work do I have to show? Well, to solve an absolute value equation that has 2 goalposts, you gotta drop the absolute value bars. So watch, look here. I take the 3x plus 3, or 5x plus 3 that's in the first absolute value, and put it equal to the math problem in the second absolute value. I don't change it at all. Write that down. Notice I put the word or there. Absolute value equations are always an or. Now watch. I take the first absolute value without the bars, and I put it equal to the opposite of everything inside the absolute value, because I'm gonna get the other side. So if there's 2 terms there, both of the terms have to have an opposite side. Now you gotta solve these 2 math problems, this guy and that guy. When you solve it, you put your answer in those funky brackets, -7 2s and 11. The only thing new I'm teaching you today is how to get rid of the absolute value bars. And there's some kinky things that you have to do. So you have to have really good notes, so you know, oh, I got 2 absolute value bars, here's what you gotta do. The first one, you don't change any signs, you just put what's inside both of the football goalposts. But the second one, you gotta take the second goalpost and make everything its opposite. Easy peasy? Okay, let's go to the third, or the second part of today's lesson. What happens if it's an inequality? What happens if I say every road in Tucson has to be 25 feet or 24 and a half feet, less than 25 feet? It can be a little bit less, and this is true. Your roads, if you go out there and measure your road, has to be, a perfect road is 25 feet. Everybody gets 12 and a half feet on each side. But you know they're using machines, right? Or they might hit a big rock or something, and the road isn't always straight, it's got some curves in it. Or have you ever been down a road that it's like, ooh, that was a little close? You know? Well, that's probably because you're hitting a 24 and a half foot section of that road, and as long as it's 24 and a half foot to 25 and a half foot, the city says you can drive on it. If it's less than 24 and a half foot, they don't want that because people will get in an accident, and the city can be sued because the road isn't correct. So they're always out there measuring to make sure that it's exactly 25 foot or within that 24 and a half to 25 and a half foot range. All right, so this is a math problem using a less than, so circle that on your paper. Put it in, highlight it, whatever. If I give you an absolute value bar with an inequality, that's where you write a sandwich, or last class, I called it a hamburger. You remember that? Where we did an inequality less than? So watch, I take what's inside the absolute value bar and bring it down, and then I bring down the same sign and the exact same number. Do you see that? Write it down on your notes. What you do over in front of it is you have to put another inequality sign that matches this one. But what are we gonna put on the other side? Negative 5. See, we're always doing the positives where Fido is and the negative of where Fido is. Now you got a math problem. Guess what? That's on your homework. Guess what? This one's on your quiz with inequality. And now we've got to add 4, 3 places, right, to get Mr. X by itself. So now I want all the x's, what is this? Greater than -1, but less than 9. That's telling me what the hamburger looks like inside. Greater than -1 goes this way, less than 9 goes that way, and we write it in interval notation. Okay, my board moved. How's that? Okay, so now let's go and try a problem with an inequality. Here's a math problem I'm going to give you on your homework. You never play with an inequality unless it's isolated. Did you hear me? Unless it's isolated. You can't play with an absolute value bar because that's just like a shorthand. It's not actual words, you know, you're using shorthand symbols for 2 parts of the math problem. So now I'm going to subtract 9 from both sides first to isolate the absolute value. Okay, so an absolute value is less than or equal to -2. Is that possible?
No.
Absolute value has to have a value of a positive number. So I'm saying I want this positive number to be less than a negative. Is that possible?
No.
What's less than -2? -3, -4, -5, -6, -20, yeah.
So if it was, the absolute value of 3x minus 2 is greater than or equal to -2?
You're doing my next problem, so you're gonna be, you got the next problem coming. All right, so good question. All right, so this one, because that absolute value is saying, I'm giving you a distance, and this distance has to be positive, And you're saying you want all my answers to be a negative number, that's not possible. So you have no solution, so your answer is empty set again. Does that make sense? You always have to analyze this step right here with the football goalposts, and it's gotta have some positives over here, otherwise it's a junky problem. Okay, we're gonna try this. I want you to work with your partner. If your partner's not here, will you guys sorta adopt whoever's extra in your class? And I want you to number, this is the original problem. I want you to go through this list and tell me what would your next step work look like? And put a 2 in front of it. Then what's your next step work going to look like? What's your next step work gonna look like? See if you can analyze the major steps you would need to solve this problem. Go. Which one would you do next?
Sides outside of
This one.
was it one's the absolute value in our one
No, it would be minus. Yeah. So this is 16. So this is 1. So it's
Four first.
So it would be just be 1, 2, 3. Yeah.
Okay.
Okay, done?
We have it right there. Yeah.
Okay, I didn't show a step of work, but what you gotta learn how to do with these absolute value inequalities is you have to know, what do I do first? And the first thing you wanna do is isolate the football goalpost. You can't have any players on that side. That guy's gotta be isolated, and on the right-hand side, it's gotta be a positive number, or if it's a negative number, then it's gotta be a greater than. We'll get into that in a minute, but that's your second step. Once that goalpost is isolated, your next step is to get rid of the goalposts. And to do that, I've got to, because it's a less than problem, I gotta make a hamburger. Okay? Once you get the hamburger, now I've gotta get Mr. X by itself, so here's getting the X by itself, and I subtracted 3 from both sides. And now here's the answer written in,
Shouldn't the other side be 16?
Yeah.
huh?
Shouldn't this side be 16? The positive side?
Yes, I didn't write this. So this should be a 16?
Right.
Error, I didn't catch it, so you guys get extra credit for it. Not yet, you gotta get 5. Nice job.
Thank you, bro.
Okay, I didn't write this, so it's not my fault, but I didn't check it, yes.
So after we've isolated is then when we can make the OR equation, or can we?
Yeah,
do it
you
before?
could, or there is no or on this one, it's not an equal sign.
Okay,
We're on the less
Yeah.
than's now, and you're gonna make a hamburger. Look, you're gonna do this problem, no or. If it had an equal sign,
it's
there
a
would,
compound, that makes it a compound,
Yes.
inequality.
yes. What's on your quiz today? What's on your homework today? This is what you did for me today. I'm going back, in my class, you know, you miss a class, it's hard to come back and get the next class, cause we're relating to the one we just had. Every day it works this way in the class. Okay, let's go to the next one. Circle this. That's a greater than. And when you have a greater than symbol with a football goalpost, isn't this weekend Super Bowl? Next weekend. Next weekend, okay. Isn't this apropos that I'm talking football? Okay, never tell me my class is junk, I'll always relate it to everything. All right, so when you have an absolute value with a greater than a number, that's when you write this on your paper and you do need the word or. My husband is greater than 6 foot, or he's got sort of blonde hair. All right, let's look at your work. I have an absolute value. I got some junk on the outside. Think of these as the players on the field. You gotta get the football goalpost always by itself. So the first thing I'm gonna do is subtract 2 from both sides, and that's where I get that 5. I'm not gonna change the inequality sign, because you only change the inequality sign when you multiply or divide by a negative, right? That's what we learned last Monday. So I haven't done that. Now I have my football goalpost all by itself on one side of the field, and on the other side I have a number. So now it's a greater than. When it's a greater than, it's an or statement. Whoops. Greater than, it's an or statement. And notice I put what's in the goalpost, and I just copy what I see. Greater than 5, or put what's in the goalpost, but now watch. You gotta change the inequality sign. Write that in your notes. And you gotta make the number its opposite. Oh my gosh, really? There's 2 things you gotta do. When it's a greater than problem, there's a lot of work to do. This is the hardest kind of problem. You write the math problem with the algebra that's in the football goalpost, and you write exactly the symbol and exactly the number. Put an or, write what's in the football goalpost, but now make it a less than or equal to, because it was a greater than or equal to, it's gotta be opposite. And then it's gotta be -5, because we want all the numbers greater than -5 or greater than +5 is where Fido is. And when I do absolute value on those negatives, it's gonna come out positive anyway. That's the cool thing, it'll tell me how many blocks away my good old Fido is. All right, so we go and solve this. This is on your quiz today. When there's an or and it's an inequality, you solve both, and then you write your 2 intervals. Write that down. What do we put between the 2 intervals? Union, a cup. You're gonna throw all these answers. That's how I remember it. I put a U there because I want all the answers from the left side and all the answers from the right side. So I'm putting everything in my coffee cup up here. Now, what happens if I have an inequality, a greater than? I have my football goalpost, and it says, tell me when this value is gonna be greater than -6. It's always going to be. Absolute value is always a positive, do you agree?
Mhm.
So,
Oh,
here's one
yes.
where you don't have any work. Highlight that, circle it. Hee-haw, I will give you these kinds of problems. And your answer is going to be the negative infinity, positive infinity. That's this guy. Neg infinity, positive infinity. Because absolute value stands for a positive number, I don't know what this is gonna be. You could put in a million, a jillion, a quadrillion. To get it out of the absolute value, it has to come out as a positive. So if I put in -90 plus 10 gives me -80, But to get it out of the absolute value, it's gotta come out as positive 80. That's what the absolute value means. There is no negative things in this whole world. Isn't that the word? That's what this is saying. Everything is always gonna be a positive. You're always gonna get money. Okay. Try this one with your partner. I gave you the first part of the problem. What's the first thing you're gonna do? And see if you can find it on there. Talk to your partner.
We're gonna add two. Syntax. Add two. Add two.
Talk to your partner. The more you chop it, walk it, eat it, drink it, smoke it, the better off you're gonna be. Don't erase, cross it out. Never erase, cross out what you wrote, put the correct answer down. Cause that'll tell you what you did wrong.
Because you do the opposite, the inverse of this multiplication. So sometimes some multiplication will do the inverse of multiplication, which is division. For sure.
So I divided by three, and now we've just got x plus four.
Absolute
The
value.
absolute value of x plus four is greater than one. So now we've got our or. I've been corrected.
Okay, what's the first thing you always have to do? We've gotta isolate this absolute value, and we got two things that are sitting outside on my football field on that side. I gotta get rid of those both before I can ever solve. If it says solve, I gotta get rid of that 3 on the outside and the -2. You always get rid of the added number first. So when I add 2 to both sides here, I now get this problem here. I look at my math problem again and I go, are my football goalposts all by themselves? No. I gotta multiply it by 3 on the outside. How do I multiply by 3? Get rid of it, divide each side by 3. Now I should have the football goalposts greater than or equal to 3, or 1. Here I am here. At that point, you take a deep breath, because when those football goalposts are by itself on one side of the field, and you got the players on the other side, that's when you're going back to tonight's homework. You take and you write it without the football goalposts, and I always write this one down first, exactly what I see. X plus 4 greater than or equal to 1. I always put that one first, because I don't have to think about that, just drop the football goalposts. Then the second one, I've got to change the inequality sign, put an arrow there, and change the sign of my digit. I got to make it its opposite, because I want all the numbers greater than -1, or I want all, or less than -1, and I want all the numbers greater than +1. I want all the numbers on this side, not me, but this side or this side. And because the absolute values are there, when I go back to the original problem, it'll always be a positive number. Yeah?
Which, digits, so not the variable, but will we make that a -4 and a -1 on our second?
No, just the number.
Which, those are both numbers?
Yeah, no, but look, this guy is not changing.
Okay.
The only time it changes when you have an absolute value equal to an absolute value, then you're gonna change what's inside. That was a couple slides ago. I know where you're confused. Okay, all I'm going to change is the digit, whatever this digit is, to its opposite. And also I gotta flip the sign when it's a greater than.
So just the one on the other side of the operator, so
Yes.
one becomes -1, not
Yes.
leave the formula.
Yep, see, it became -1, but I also switched, instead of a greater than symbol, which was the original problem, I now put a less than or equal to symbol with that negative value. All right, with your group, I want you to tell me what your first step will be for problem 1, 2, and 3. See if you got your steps down. Every step, you have to get rid of the football goalposts. I've already isolated it for you. Now tell me what your first math step will be. If I give you this kind of problem for your homework, what's my first step gonna be? If I give you this kind of problem with the less than, what's my first step going to be? And if I give you this kind of problem with the greater than, what will my work be? Talk to your partner.
I have no clue what she's talking about.
After dropping the bars.
You're taking away what I'm asking you to do,
The absolute
from
value.
outside, bracket
It is,
on the inside.
and then add 2.
But, I don't know how to specify that
Or,
versus
good,
what it
keep
was
going.
originally multiplied.
Or
So, how to
Whatever's
specify
in the
just
plus
football.
2.
like it where
Maybe
it's
5,
take
yeah.
Yep.
those things away.
Same thing. Yeah, 3.
Yes, or adding 2, or what on that.
Yeah, subtract 2.
Oh, what? Yes. I agree. You added 3 first? Okay.
When it's a less than, the two signs have to match each other. So you put a less than on the right side. I just bring down what's in the absolute value bars and copy what's over on the right side. Then on the left side, I bring a less than symbol down again, but put a -5 on the other side.
So you can make 2 equations, right? But you don't need to put the word or.
No, you put the word and if you want. This is a special and problem, like that. The sandwich,
So and.
it's an and. So you could say x plus 2 is less than 5, and x plus 2 is
Negative.
greater than -5. I wouldn't do that, I'd write it as a sandwich. Sandwich is much easier. When it's a less than, you gotta do a sandwich, you wanna eat less, so you don't get over full.
And X minus.
So I always do the sandwich. So if I have an absolute value of 3x plus 2 is less than, let's say, 10, my first step is just copying what's in the absolute value, copy this, and then I just go like this, and now I'm ready to start solving. Lessons, I think, are a piece of cake. The hard ones are the greater than, because you gotta flip 2 things. You gotta flip the inequality sign and the negative for the second problem. And you gotta remember that it's an or, and if you don't put 4 there, she's gonna be a mean wench and take off points. Alright, so that one's an or. So again, my first step, look, I take this and my first step is right underneath it. If it was my work, right underneath it, I write it without its absolute value bars. And then what I do is I put the or over here, and then I take the absolute value, switch the sign, switch the number. Now I got my two problems. Those of you that had me last semester, what's my last slide?
The best.
How do we use the label?
Huh?
How do we use this in the label?
I gave you one example. Now I'm gonna show you the math problem they're doing in the city of Tucson. Anytime, you know, I live in Vail, and in Vail, we got new developments going every other day. And every other day, they're putting in roads. And so every day in my town, they're doing this problem. The width of the street, take away what its actual length is, it has to be 25, has to be less than a half a foot. Either a half foot more or a half foot less, but it's gotta be no more than 25 and a half feet, no less than 24 and a half feet. Otherwise, they're gonna close the road down on me when they come and inspect it. This is the math problem they're doing anytime they build any street in Tucson. Whatever your length is, you just put an algebra W or whatever letter you want, minus the length that you have to have it, and this is the variance. It's the little, what do they call it here? Tolerable. It's the tolerable amount. The road can be a little bit over a half foot, or a little bit over 25, or a little under 25, but anything else, rebuild that road, buddy, you're not gonna let cars down it. Now you're going, okay, I get that, I get that, I get that, but what else? How many of you know what Ross is? Am I the only old person in the room? Yay, I love Ross. Ross. Everything I wear, Ross. What's Ross?
Oh, you're talking about the
That's
store?
it.
Yeah.
Oh,
Oh, you thought I was talking math? Nah, we don't talk math. What's Ross?
Shopping.
Sorta. Retail store that is a big what? Huh? Corporation, yes, but what is, discount, it's a discount store. Don't you guys go to Ross's? You can get really good deals at Ross's. All right, when I go to Ross's, how about TJ Maxx? You guys like TJ Maxx? What's the other one? Here's an M.
Marshalls.
Marshalls. Okay, you like those stores? Why are those stores in existence? Because of my math lesson today. You see, I bought this sweater at Ross's. And it might be a small, it might be a medium, it's not those. It might be a large, might be an extra large, who knows? But when it was built or made, it didn't fit the requirements for your big retail stores or your Amazon or wherever you might be getting your stuff. That would, you know, they would charge me $50 for this sweater. You know what I paid? $6.99 because I'm a senior citizen and I shop on Tuesdays. All right, anyway, it's not $50. Why isn't it $50? Because when they put it down on their measurement, wherever they made this sweater, they put it down on a measurement and it was either too big or too small. So they can't put a large on it, they can't put a medium on it, it's somewhere in between. The tolerance wasn't right. So they ship crap to these stores that aren't just quite right. Have you ever gone to the store and you put on a pair of jeans and it's a small and you usually wear a small and it's like, I can't put my big foot in it. Why? Because it wasn't made right. The tolerance level for that measurement wasn't correct. So, you look at your phones. When you look at your phones and you sit there and say, oh, your phone's a little heavier than mine, all phones aren't the same. When I used to teach this lesson in high school, I used to go to the store and buy a box of cereal that had in some Raisin Bran or whatever in it. And I'd make the kids in their groups pour out their cereal box and count how many raisins are in the box. So I might have 8 of the boxes in the room. How many boxes had exactly the same amount of raisins in it? None. You see, when you buy something and it says 6 ounces on it, you assume that my phone is gonna weigh 6 ounces. But your phone, which is the exact same phone as this phone, this phone, this phone, they don't all weigh the same. There's a tolerance level in there. Everything that's on your body has a tolerance level. Everything on your body is an inequality. You bought that shirt, those pairs of pants, those shoes that are size 7, size 9, whatever. Have you ever tried on a pair of shoes that's your shoe size and it's got, you go, gosh, these are small. Doesn't feel right. It's because it was just barely at the tolerance for that size. Everything that's on your body, in your house, in this room, is an inequality of an absolute value that I'm talking about today. Really? Yeah. You gotta learn how to relate this math to your everyday life so you don't forget it, number one, until the exam at least. But again, if you know more about how math is related, my son has his own business, and he goes, Mom, I can't thank you enough since he was a little snot. I used to make him sit on the toilet and he had to recite the multiplication tables to me because math is so important. Everything in your life is about math. And as soon as you realize that and practice it, math becomes a lot easier for you. All right. The big thing I want to talk to you about is right here, your salary. When you go and apply for a job and you sit there and your employer, and the employer says, well, how much do you want to make this year? And you sit there and look at your mortgage, you look at your car payment, you look at the new TV you bought for the Super Bowl, you put in your weekly food and all that, you have what's called a budget. And your income has to match that budget, but if you're good, it'll be plus or minus maybe $50 or $100 or whatever. So one month you might have an extra $100, the next month you need that $100. That's the way I work. Oh, taxes are coming up in April. I better start saving some money for my taxes that I'm gonna have to pay. All right, so Bob is looking for a job. The salary he has to have is $3,000 a month, but he's got a tolerance of $500. What does that mean? He can have a job that's $3,500, or he can have a job that's $2,500. That's the tolerance. You know, that's FIDO on both sides. It can be 500 or neg 500, or less than that. Look, less than 500. But when I put absolute values around it, I'm looking at the 500 above $3,000 or the 500 below $3,000, and he's still going to survive. Have you ever watched a baseball game? And you'll see the catcher throw the pitcher a ball, and he'll go like this, and then he goes and throws it back to him. Have you ever seen that?
Mm-hmm.
Why does he do that? Because those guys are so good that they know that every baseball that's made, every football that's made, every basketball that's made are not the exact size, same size and weight. But they're so good at their sport that he feels the ball, and if it's not perfect, 5.125 ounces, 5 1/8 ounces, they can feel it and they'll go, ooh, this is a bad ball. And they throw it back because they know that they want a perfect ball to throw to get that guy out. I want you to leave this room saying, oh my gosh, the whole world is an absolute value inequality. It is. But you have to understand what it means. It's called a tolerance. So I've given you some examples. Whenever you go and buy, here, let me give you this, look. I always start choking, so I have these sitting on my desk. I could have brought each group one of these today. I should have. And made you count them. You know how many of you would have the same number in each of your containers? Not very many. There might be, there might be 50 in here or whatever. Does it say how many are in here? No, it gives you the weight. And that weight is a tolerance. So that some of these packages will have 50 little lozengers, some will have what? 49. There's a tolerance level that when they made these, they decided the weight has to be whatever it is, 0.5 milligrams or whatever. And they don't know how many are in here, because some of them might be a little heavier, some might be a little lighter. And how many of those can you fit in and still be within that weight? Everything in the grocery store is an absolute value. How much cereal you get. How much steak you get. In a soup can, you guys think you get the same amount in every soup can? You don't. It's an absolute value. Okay, I'm done. See, I'm done 20 minutes early. Here's the answers for the next quiz. You can either take a picture of it, or if you go to D2L and you look at day 4, you'll see a practice quiz there. And in D2L, I always give you the answers there also. But you can take a picture of it, or you can write it down if you want to write it down. Now, today is not a group quiz. It's not a take-home quiz. You gotta finish the quiz today. But you can use your practice quiz if you worked on that with somebody or did that. You can use your homework from today, or you can use your notes from last Monday to do the quiz, but you may not do it with a partner. Now, if you got a question and you want to show me the practice quiz, I'll help you on the practice quiz before you do your quiz, but I can't answer a question from the quiz. Don't forget to hand in any homework you have that goes with that quiz, day 3 homework. Don't forget that you, if you haven't turned in day 2 or day 1, you might want to turn that in also, okay? Questions, comments? The recipe is yours when you're done with your quiz. Put your homework in it if you have it, and then you're free to leave. You're free to leave anyway, but